Chapter 2, and we're going to finish up with our geographic perspective, the solar economy. So, we've talked about sunlight and heat, and I've mentioned a few times that it is a form of energy, right? Well, we've also used energy in our economy. So, if you think about the global economy, right, the electricity that we need to power our cities and factories, the fuel that we need to drive our trucks and cars and airplanes, this relies on what we call fossil fuels, the non renewable fuels like oil, natural gas. And almost all of our economic activities that use energy use these type of fuels, over 85%. But the big problem, as you've probably heard many times and are well aware of, is that when we use fossil fuel, the burning of it pollutes the air. It causes health problems, right? And another thing that really hasn't been talked about as much, it used to be, was that fossil fuels, as we'll talk about, are inherently non renewable. In other words, once you use them, they're gone, they're not coming back. So, if there is a finite amount of fossil fuels, which many people believe there is only so much oil and coal on the earth, and if we run out of them, then what are we going to do? Well, one of the ideas is moving towards renewable energies, energies that do not get used up. When you burn coal, it's gone. You don't get more coal. But if you use the wind to power a windmill or solar energy, there's always more solar energy coming, and there will be for the next 4.5 billion years, as far as we can tell, right? When you use windmills, you don't take up the wind. There's still more wind. So these energy sources, they're renewable. They don't get used up. And another benefit is that, for the most part, most renewable energy is carbon free. What that means is, remember, when we burn something like coal, we release pollution like carbon or sulfur dioxide. Most renewable energy does not cause that, right? We don't release carbon when we use solar energy. And then a last plus, if we measure all of the energy we need on any given day on Earth, the average figure is about 15 terawatts. So have you ever heard about how many watts are a light bulb? It's a 100-watt light bulb. Watt is just a measure of energy. So we can say that on average we use about 15 terawatts, right? Now, if you compare that to how much energy does the sun give us every day, 101,000 terawatts. So just by that math alone, right, the sun gives us 100 times over more how much energy we actually need. So in other words, if we could find a way to harvest that somewhat, even a small percentage, right, we'd have an unlimited source of basically clean energy. Here's an example. You look at the total capacity, and this is theoretical, we don't know for sure, we can't measure every last watt, so we do a best estimate of all the different types of renewable energy that we use: solar, wind, biomass is burning plants and trees that you can regrow, or water power, all these ones. The one with the highest potential is solar. There's just so much solar energy available. And again, we only need about maybe what, don't even tell me, I can't do the math because I'm not a mathematician, but if I said 15 out of 101,000, right, we don't even need to be that efficient with solar energy to really harvest what we need. When we get solar energy, there's two ways of doing it, basically either concentrated or spread out. So decentralized solar energy, these are when we see those solar panels on the top of houses. If you ever looked at a Divvy bike station, they have them. Small ones on little lights. Some people have those lamps and their sidewalks in their yards that have a little black solar panel. When I was in grade school, I had a watch with a solar panel. Individual spread out needs. There's actually solar roadways. Some roads have been designed to capture solar energy. And then you can also have basically like a solar energy plant, a centralized location, like a solar farm. And here's what that looks like. Right here in Spain, this is a series of mirrors. And the mirrors can rotate and they follow the sun. And what they do is they follow the sun all day and reflect all the sunlight right here to the top of this tower. And it heats up inside of here a big tank of water, which turns the water into steam. And we can use that steam to make electricity, actually. If you ever held a magnifying glass and the sunlight, you can actually light things on fire. It's the same thing. You're basically focusing the solar energy in the form of light and heat right here. This right here in Nevada is just the traditional solar panel. But what it is, it's a big, huge field full of them. And again, they're mounted to follow the sun all day. And then this energy is collected just like a power plant where they burn coal or gas and is put into the electrical grid. If we look at the Earth, this measures what's the average sunlight. How much sun do they get on any given day? And as you would imagine, here in the deserts, right, you get a lot of sunlight. You get more sunlight in the desert than you do up here in Chicago, right? We have colder winter days. Farther north, right, the days are shorter in the winter. So you see, not the entire world has the same potential, right? Some areas have much more potential for solar energy than others. That's one of the challenges. So first of all, we need some type of solar panel or something to convert this energy. So solar panels that we see right now are about 30% effective, which means that for 100% of the energy they absorb from the sun, they can make 30% of that into electricity, which is pretty good. It needs to get better because you think about it, right? If you only use that much, it's a lot of space. Secondly, where are you going to build these big solar farms? So let's go back, right? Not every area is equally accessible. So maybe we'll put them here in the middle of the Sahara Desert, you say, right? Wide open empty spaces, or up here in Tibet. And that's true. I mean, they are pretty empty, but even empty spaces still have wildlife habitats to deal with. So we need to be careful of that. Another aspect is transportation. If you build these solar farms in the middle of the desert, how do you get that electricity to the cities where people live? Electricity, if you put it in the power lines, you make it in a plant, it goes up in the power lines that we see, those grids. For every mile it travels, it loses a little bit. So the further you build the source of energy, the solar plant, from where it's being used, the cities, the more is lost. And so that's something to keep in mind as well. But the big thing is politics. Because here's the thing. Solar energy has the potential to revolutionize the way we use energy. It's clean, it's relatively affordable, it's free. Currently, energy is dominated by the fossil fuel industry, people that drill for oil. One of the biggest corporations in the world is Exxon. So you have to think about this. Is it in Exxon's best interest financially, economically, to see a world where oil is no longer valuable? And the answer to that is no, it's not. And you also look at the connection of money and politics and power. And there's a lot of fossil fuel industry leading companies in higher levels of society. They have a lot of access. Our former Secretary of State, which is one of the highest ranking diplomats in our country, was the chief executive officer of Exxon at one point. So there's that definite connection. And so that is one of the challenges that you often hear, that clean or green energy doesn't work. And a lot of times you have to wonder, well, who's saying it doesn't work? And for what reasons? I will leave you with this. And one of the reasons I teach this class is this. Henry Ford became one of the wealthiest men in the world. So did Thomas Edison. Thomas Edison, what did he do? Oh, he made the light bulb. He didn't invent the light bulb. That actually had been around for 100 years. But what he did was he made a light bulb that everyone could afford, everyone could use, and he became wealthy. Henry Ford did not invent the car. The automobile had been around for about 100 years before Henry Ford made them in Detroit. But what Henry Ford did was he took something that was so expensive that only the wealthiest of the wealthy could afford and made it so everybody could have a car. And when everybody had a car, everybody bought a Ford. So if you are the person that can answer these questions, you can design a solar panel that is 85% efficient. You can design a way to transfer solar power built or created in the desert to Los Angeles. If you can find a way to overcome those issues, politics aside, let's just be honest, you're going to be wealthy beyond your dreams, because if you can harvest the energy of the sun, there's a desire for this clean and green energy in many ways. So, you're thinking about what's going to happen in the future. Well, you guys are the future, and that's my little spiel for today. I'll let you go off and have your cup of coffee, and I'll see you for the next chapter.